Hello again, and welcome to 5-Minute Physics. Today's topic is the comparison of AC and DC currents. AC and DC currents are the two types of electric current that are used in the world today. AC stands for alternating current, and DC stands for direct current. The biggest difference between these two is the way that they move. AC currents move by the AC currents transmit the current through the back and forth motion of the electrons. So you'll have a wire, and that'll be full of electrons. Let's just imagine here. And their vibrating back and forth is what carries the current along. They actually don't go anywhere, they just kind of oscillate back and forth. And that produces the current that flows through the wire. AC current was discovered in France in 1832 by a man named Hippolyte Pixii. Alternating current functions much in the same way that a transverse wave does, with the energy of the particle. So it's displacement, I suppose, moving from its original position, positive, negative, positive, negative, again, with the back and forth vibration. The electrons in the conductor move back and forth, or alternate. Alright, now in DC circuits, or not DC circuits, direct current, DC was first recognized by Thomas Edison in the 1800s, and it's characterized by the motion of electrons through the conductor. So if you have the same wire, it's just a bendy wire, the electrons will actually move through this wire, very slowly albeit, but they do move. It's called direct because they do flow. And the difference here is that the current, I, moves in the direction opposite to the motion of the electrons, which is a bit of a weird thing, but that's the way DC works. So, in this fashion, electrons are, quote, pulled from one end to the other by the strength of the electric field surrounding the system. So, much in the same way that evaporating water through a tree pulls water from the roots to the leaves, you get the charges on the electrons. Well, actually, they're all negative, but they do pull each other along. But not to oversimplify, they do a lot of bouncing around before they get anywhere. So if you have an electron inside of a wire here, it's not just going to go like this. No, it bounces off of everything because electrons go among all substances, and so you actually end up with something like this going on, where they bounce erratically in all kinds of directions before moving forward. So they end up actually going this way very, very slowly. Again, although there is a significant amount of resistance that arises from these electrons bouncing off of stuff, direct current does transfer a great deal of energy. It's not fast, but the electrical potential energy of a DC circuit can be immense. In fact, when Edison was trying to show up Tesla, it's interesting, they had this big argument, not an argument so much as a competition, I suppose, between Edison and Tesla, with Edison, I think I spelled that wrong, being a big proponent of DC current, and Tesla being a big proponent of AC current. And Edison liked to do a bunch of demonstrations to prove Tesla wrong, to prove that AC was much more dangerous than DC. In fact, that is not the case. However, he did have some fairly interesting demonstrations. For example, at one point he electrocuted an elephant with using AC current to display how dangerous it was. Of course, this was before we found out that DC was much more dangerous than AC, but such is life. So that's it for direct and alternating currents. Thanks for watching, and I'll see you next time.